Everyone, today I want to study experimentally the time period of simple pendulum and as well as verify the value of G, which is 9.8, with the help of the simple pendulum. Today the other one thing that I want to investigate here is such that the time period of simple pendulum is independent upon the mass of the bob of the pendulum, because we know that the time period of simple pendulum T is equal to 2 pi L by G, so there is no term involved related to the mass of the simple pendulum. So that's why today I want to experimentally verify that the time period of simple pendulum is independent upon the mass of the bob, as well as I want to study experimentally the value of G, which is of 9.8 meter per second, with the help of the simple pendulum, such that how 9.8 meter per second comes with the help of the pendulum calculation. So for this experiment we required bob, an extensible string, stand. Besides these, or along these, we required stopwatch for this experiment, as well as a meter rod and white paper for calculation. So now first you have to note the diameter of the bob with the help of the vernier caliper, and then take or find the radius. After that, when you find the radius, then also measure the length of the thread and add the length of the thread to the radius of the bob. So you get the final result, and then you add them and get the final result. Here I measured with the help of meter rod the total length, which is 42 centimeter. So the length of the inextensible string plus the radius of the bob is of 42 centimeter for this experiment. So note it first. Now I want to count the number of oscillations and the time taken by the oscillations for this experiment. So let's start counting and noting the time with the help of stopwatch for this experiment. So let's start this experiment and noting the time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So here you see that round about 26 seconds is the time taken by the oscillation of the pendulum. So the total time for us is 26. Now let's focus on this paper, such that you people already know that time period of simple pendulum T is equal to 2 pi L by G. Now by squaring both sides we get the value of G, which is 4 pi square L by T square. Now the length of the thread plus the radius of the bob that we measure is basically here 42 centimeter, and converting it into meters we get 0.42 meter, which is the length of the inextensible string. Now we already noted here that the time taken by the 20 oscillation is of 26 seconds, and the number of oscillations that we noted here is of 20 seconds. So by dividing the time taken by the oscillation divided by the number of oscillation, we get the time period of this pendulum. So time period for our this experimental measurement of the pendulum is 1.3 second. Now as we know that here the square of t is involved, so by squaring the time period we get 1.69 second. So we calculate time for this experiment. We already noted the length of the inextensible string of the pendulum by putting the values In this equation you see here that 4 multiplied by 3.14 square cross the length is 0.42 meter and the time is square of time is 1.69. So result of these values comes 9.80 meter per second square, which is basically the value of G, which is 9.8 meter per second. So this is basically, you see here that very clear and very beautiful result that the value of G is 9.8 meter per second. That is basically the free fall acceleration for any object, whether the object are lighter or heavier or fall with this acceleration due to gravity. So this is the experimental verification of the acceleration due to gravity, or the G, which is 9.8 meter per second square, with the help of the simple pendulum. Now today our another main concern is that the time period of simple pendulum is independent upon the mass of the bob. So now let's focus again on this experiment. This bob is heavier. Now I take another bob and remain and taking the constant same length. You see here that the length of these bobs, I taken this length equal, and by changing only the bob and taking the length constant, let's study the effect on the time period of simple pendulum such that whether the time period is affected or not. Now I am going to noting again the time and the number of oscillations and checking whether the time period affected or not. So let's start counting and taking noting the time. So let's start. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. Again you see very clear here that the 20 vibration taking time of 26 seconds. It means that if we take heavier bob or a lighter bob, the time taken by the number of vibrations remains the same. If we again divide this 26 second time on the 20 vibrations, we get again the 1.3 second time, which means that the time period of simple pendulum is independent upon the mass of the bob. So this is our today experiment. I hope you learn some interesting results experimentally that I verify here that the value of G is 9.8 with the help of simple pendulum, as well as I already experimentally verify that the time period of simple pendulum is independent upon the mass of the bob. So thanks for your time. Please like and subscribe my channel if you like this video. Thanks for your